Thank you very much for coming to the last session of this Spring I/O, which is an amazing conference. And today I'm going to speak about zero downtime deployment in Microsoft microservices era, and more specifically when you start using service meshes. And I mean, the examples are running in with a Spring or a Spring Boot, but of course, I mean, it's the same thing can be applied to any other technology, even non-Java technology. My name is Alex Soto, I work in Red Hat. I'm the curator of Lord of the Jars, and if you like this logo, which is Duke, I mean, this is a wizard Duke. I have some stickers. After the session, if you want, you can take some of them. Also, I'm the co-author of Testing Java Microservices, and there is a raffle of one electronic book. So if you follow me on Twitter with a picture of the session, you mention me and with the hashtag SpringIO, then I will, raffle a discount count of 100% of the electronic book. So you can go to manning.com and then you just download the book. If there is any question, just please stop me and say, I have a question, and I will answer it on the context. I mean, at the end, probably we will have some time, but if not, I mean that you can do it at any time. It's not a problem. So let's just start. Probably some years ago, I mean that now it seems ages, we developed something like this. It was like, a big monolith application where everything was, inside. In fact, it was something like this. I mean that we have some modules inside, composing all the application, and even inside each module, we could have some, some components. And if you think about this architecture, you see that this is really easy to deploy, right? You have that a WAR file or a jar file, it doesn't matter, but it was a big application where you just run it and it works. And the good thing is that usually with the monolith, you didn't deploy several times per day, but you deployed maybe once per month. Well, probably some of you will say one per month. It was like one every 6 months. Okay, right, one every 6 months. But it was really easy, right? Because you could even wait until 1 a.m. and at 1 a.m. you just send the maintenance page, you swap the application, and that's all. The deployment is done. Almost zero downtime deployments. The problem is that 2 years back, we start thinking about breaking this monolith application to something like this. We started with microservices, right? And then we have something like this. All these modules, all these components are spread across a mesh, all of them interconnected by network. And as you can see, this is a graph structure. It's not a tree. It's a graph where all the services can be interconnected between them. So it's really quite interesting. Even some of the services might have a database, and each of the services has their own database, and even multiple points of entry. Some services might have access to the external wall. And yet, for this reason, it's a good idea to always have an API gateway in front to just support this use case. The problem is that usually microservices are deployed independently. With Monolith, you just have all or nothing. But with microservices, you might decide to deploy a new version of one of these services multiple times per day. So as you can see now, the problem of downtime is quite more interesting, because what's happened if there is downtime in this service? Maybe because we are updating this service. The thing is that there is a cascade of errors. So there is a lot of failures. Basically, all the transitive services that are depending to the service are failing as well. So now, zero downtime deployment is really important. But the first thing that we need to think about it, how we do zero downtime deployments, is that now deploy is different than release. And this is really important. In the past, in the monolith application, we usually said, I'm going to deploy the application, which basically means take this application and put it on production. And let's say that it was equal saying deploy or release. But with microservices, this has changed. Now, one thing is deploy a service, which means putting inside the production cluster. And another thing is saying release the service, which means start sending some traffic to this service. So this is really important to start doing zero downtime deployments in the microservices era. There are several techniques. I'm going to explain the common ones. We're going to see also some demos so you can get the idea. The first one is blue-green deployments. Probably most of you knows what is blue-green deployments. Just as a reminding that we've got all our traffic that are going to the blue environment, and then we've got a build, which is a new version of my service. So basically I put it on production. So this means that I'm deploying to production and then I'm releasing, which basically means changing the routing from the blue to the green. And we do not undeploy the blue. The blue is still there. And the reason that it's still there is because when you are doing this change, you can start monitoring this service. Maybe you're using Prometheus, then you just check Prometheus, and if everything goes as expected, then you leave this route. But if there is an error, you can just really quickly change from green to blue. And that's a really easy technique, but it has one big problem. And the problem is that all your clients are affected if there is a failure. So if you are created a new version of your service, you deploy it, you release it, and then there is a really big error, then all your clients will start getting this error. For this reason, what was created was like Canary Release. Probably most of you already knows Canary Release, which basically comes from the coal mines, right? That in the past in the coal mines there was some poison gases, and there was no way to detect these poison gases. So basically, what the miners did was just taking a bird and go inside the mine with the bird. And the good thing for the humans, but not for the birds, is that the birds dies after 30 seconds of getting these poison gases. Meanwhile, the humans, it just takes 2 minutes. So it means that the miners, when they saw that the bird was died, it means that they had 1.5 minutes to just go out from the mining. And this is exactly what we're going to do. Not with a canary, because, that we are software engineers, but with software. So we've got all our blue environment. That this doesn't matter. That we have our service, the old service version. All the traffic goes through there. We have this yellow bullet, which is the new version. And then we put this new version inside the old version, and we start sending, for example, the 10% of the traffic. So you send the 10% of the traffic. If everything works as expected, we can increase. And if not, we can just remove this new version. So you have the 10%, if it works, 25, 50%, 75%, and finally 100%. So in this way, we are not affecting all the users, but just a small portion of the users. Again, this have another big problem, is that if you don't have a lot of users per second, that would be fine. But what's happening if you are Facebook? 10% of your users are really a big amount of users that you are affecting with a possible problem. So basically, Google and Facebook have started doing one kind of techniques. This is an umbrella of techniques called dark launches, which basically, dark launches is a set of techniques that to test on production without the end user noticing it, that you are using their own traffic to test your new version. And there are several techniques. Usually, for example, Facebook uses one technique which is called dark canaries, which is something similar like Canary Releases, but instead of using the percentage of traffic, they are using, for example, range of IPs. So if you are an employee of Facebook, you are accessing Facebook from a certain range of IPs, basically the Facebook offices. So then you can get these IPs and say, okay, I know that this is a user of Facebook and this is an employee of Facebook, so I'm going to send the traffic to the new version of Facebook. In this way, they are going to test what's happening before I release this new version to all my users. This is called dark canaries. But in this, one of the techniques that I use, because it's really easy, is mirroring traffic. And mirroring traffic is something like that. I'm just getting my 2 versions deployed, the old one and the new one, and I'm just sending a request. Then this request is sent to both of the services, the blue and the green. But notice here that the blue, it has a double arrow, meanwhile the green is just a single arrow. The reason is that what really important from the point of view of user is the old one. So the user receives the response from the old one. And the new one, it just creates a fire and forget request. It sends a request and they don't care about the response. And this is a really interesting technique because it allows you to start monitoring your new service without checking if there is errors or not, how it's performing, without changing how your new users perceives that you have updated something. This might seem really complicated to do, but if you are just using Kubernetes, which is the de facto platform for microservices, then it's really easy. Basically, it's easy because with microservices, we need to implement all these cross-cutting concerns, which is like you need to have an API, you need to find a way to discover services, to invoke services, the elasticity, the resilience, the pipeline, the authentication, logging, monitoring, and tracing. All these cross-cutting concerns are inherently inside a microservice architecture, and this means that I can use basically all this discovery and invocation thing to define where I want to send the traffic. So with microservices, it's really easy to do. What's really happened bad is something like this, that you start with microservices and you say, okay, I need to do some kind of discovery, I need to do some kind of tracing, I need circuit breakers because there is a network. Probably all of you that are in microservices already faced this problem, and you are ended by having something like this. You've got a container, the JVM, and then you have a service, and then you have the discovery part. The discovery part is where to send the traffic, and then a load balancer, a resiliency, a metrics, and tracing. And all this logic is inside your service. The typical example is Istrix. If you got Istrix, you just take your service, add a new dependency, you annotate your service with something, and then you've got circuit breaker behavior there. Notice that what you are really doing is just taking your service with all your business logic and just adding some features that comes from the infrastructure, like doing automatic retrace or discovering other services. But what's happening if I told you that you can take all these cross-cutting concerns like discovery, circuit breakers, security, all of these things, and put it inside the infrastructure. So you grab out from your service and you add just an infrastructure layer. And this is exactly what Istio is doing. Istio is a service mesh, and a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. So if you are into microservices world and with Istio, you are getting something like this. You've got a pod, and then in this pod you've got a container, in the container you have the JVM, and then you have your service. But notice that now there is no logic referring discovery, nothing related to circuit breaker, security, nothing. But we've got a sidecar container. This is another container. So now our pods have two containers, my service and all this logic. And all this logic related to infrastructure is just inside this container. So I can reuse in all the services without having to do copy-paste. And if you want to be in details, basically in case of Istio, inside all this sidecar container, there is an envoy proxy. An envoy proxy is like Nginx or HA proxy, which basically takes the request and then manipulate this request to resending the traffic to another place, or doing automatic retrace, or managing the certificates. So what you can do with Istio, the first thing is that you can do traffic management. You can start doing things like, I want to send all the traffic to service V1, and then you just execute a command, and then all the traffic goes to service V2. Or I can say, I want to send 90% of the traffic to service V1, and 90% of the traffic to the service version 2. So it's really easy to do with Istio. Also, it allows you to do mirroring traffic. This is what we've seen of dark launches. So you can send two requests to two services. I mean that it's one service but different versions. You can also do dark canaries. So you can start doing things like, I want to send traffic that comes from Chrome to this service, and if it comes from a mobile to this other service, and if it comes from this user to this other service. So it's really easy to implement some kind of logics depending on who is connecting to your application. Also, it implements circuit breakers. I mean that this is not for, I mean that this helps in case of zero downtime deployments that are not really zero downtime deployments, because it allows you to implement some kind of automatic retries and pull ejection. This means that if I'm deploying a new service and then I start releasing, and there is some period of time, seconds, that this new service is not available, you can do some kind of retrace, which makes Istio retrying any failure to a spot that it's up and running and it's behaving correctly. So this means that if you have some downtime in the middle for 1, 2, 3 seconds, Istio will get the response of the failing service and reroute to the new service. Also, Istio helps you in chaos engineering, chaos testing. So if you want to do some kind of chaos testing of what's happening inside my services when there are some delays or there are some timeouts, you can use Istio to simulate this. Just one note about chaos engineering. I've talked with several companies and all of them tell me, yeah, we are using chaos engineering, chaos testing, and then I ask, and how is it going? And most of them tell me, whoa, it's a disaster. Right? And I said, and why are you using, or why you are starting doing chaos engineering? And the answer is, because Netflix does. And it's really fun, right? Because probably your problems are not the same as Netflix, and probably you don't have the infrastructure that Netflix have. But in any case, one of the most common problems that they told me they have is that there are some kind of emergencies, in the sense that some developer decide that it's a good time at 1 p.m. to do some chaos engineering, and they start doing their own chaos testing, and the monitoring team start seeing some kind of random errors on the services, and they say, well, what's happening here? And it's like, we are doing some chaos testing. The thing is that nobody has notified to the monitoring team that these tests are going to happen, right? So when you are going to do chaos engineering, first of all, teach yourself very well, and second one, communicate to everyone that you're going to do it. Because if not, you're going to fight some heartbreaks during the test. Also, it implements security, and this is one of the reasons why most of the Red Hat user or customers are interested in Istio. And this is because Istio allows you to communicate using MTLS, but under the covers. You as a developer, you just write things with HTTP, and then since you have this site container which receives all the traffic, then you send a request to this sidecar container. This sidecar container transforms your HTTP request to HTTPS request. It does the communication to the other service with HTTPS, to the other envoy proxy. This envoy proxy just transforms the HTTPS to HTTP, and then it reaches the service. So if you see that from the point of view of developers, you don't need to take care of managing certificates, CAs, revoking certificates, and so on, because from the point of view of developers, everything is HTTP. And implements observability, which means that it has by default with Prometheus and Jigger to check what's happening inside the mesh. So now let's see all the demos. If you have gone or you have seen other talks about zero downtime deployments, all people do exactly the same thing, which is like a hello world services, which is a stateless services that you have one service and then you send all the traffic to service B1, and then they show you that you can do a canary sending the traffic to service B2, and yes, of course it works, and it works because it's a stateless. But I want to show you here is what's happened when there is a stateful services. then it's quite more interesting, right? And even more interesting is when you start changing the schema of the database. So I'm going to start first of all with the ephemeral state. And ephemeral state are persistence that is not ephemeral. Basically, the example is the shopping cart, right? The shopping cart is something that it's persisted somehow, but it's ephemeral. If the session goes down, you lose. So, how I've done this in the past? Well, basically, I did something like this. I have my router, and then I have my version 1 of the service, and I use sticky sessions. I don't know if you are still using sticky sessions. I mean that it's really a huge problem. And basically what's happening with the sticky sessions is that it just records the IP of the request and the server who serves this request. Then if you have a shopping cart, what you're doing is that, okay, I have the sticky session there, I have the shopping cart, and I have the version 1. So all the requests of this user always reaches this version 1 service. But now, what's happened if I want to do, for example, a blue-green deployment? So I've got the version 1, I want to change to version 2. Okay, now all the reroute changes to version 2, and the user who had their own shopping cart is just seeing that there is no shopping cart because the server is not reaching any traffic. How to fix this problem? Basically, it's using an in-memory data grid. An in-memory data grid is a data structure that resides internally in RAM and is distributed among multiple services. For example, InfiniSpan, Redis, Hazelcast, all these technologies are in-memory data grid. And they are based in this, is that for any request, for any version, they are storing the shopping cart, so this ephemeral state, inside this in-memory data grid. So then when you are doing, for example, the blue, and you're switching to green, you're getting something like this. You've got the blue just disappear, but since the green is accessing the in-memory data grid, and the in-memory data grid is replicated across all the cluster, you're still getting all the shopping cart. And I'm going to show you a demo if it works, because I've noticed that there is some kind of problems with network. Yeah, okay, now I'm going to show you, wait a second. Okay. Now I'm just starting the cluster because I had some problem with network. Is there any question? Meanwhile, start. No? Yeah?
Hello? Perfect. Right, so my question is, how would you handle migrations of the data? For example, the in-memory data grid, or even if you're connecting, for example, the green and blue deployment, if you have a database behind that, how would you upgrade your data model?
This is the other example. I will explain all the steps that you need to follow. You'll see that there is like 3 steps that you need. That you create 3 intermediate versions of your new version. You'll see then with the demo and well, all the everything explained. But basically, it's following the pastel law, which is like that you need to accept everything and send just what they requires you. Basically, you'll see it now. Yeah, it's not hard. Look, well, now this is working. Hope. No. I think that this one, or hope so. Okay, So I started the wrong. Oh man. Okay, I'm going to change display. Yeah, but this is not well. Wait. Now I have this application, which this application is a movie data store. So you have that I have some movies, and I have two versions of the same shopping, not the shopping cart, it's the service who serves all the movies. So what I'm going to do is just adding some movies to one version, and then I'm going to do a blue-green deployment to another version, and you'll see that the shopping cart is never lost. And I can just go from version 1 to version 2, and then again to version 1, and the user will always have the shopping cart ready. So now that it's working, I can just this thing. Not. Okay, it's just starting. Good. Copy. Okay, now. Then what I need to do is to make this work. This is what I need to do. This is the first thing. Why it's not working? Let's say. Because Redis it's not up yet. Yes, Redis is up. No. Well, let's see now. Let's hope that now. If not, I have recorded. So, okay. The first thing that I need to do is just this is, if you can see. I've got here the movies v1, movies v2, movies gateway, and Redis, and notice that I have like 2/2. This is because I have a pod with two containers, the service and the Istio container. So the first thing that I need to do is instruct Istio that there are all these services there running. I think that it's like here. Istio-ctl create -f, so main Istio destination rules. Okay, there's already a destination rule, so I'm registering, and then the other thing that I need to do is send all the traffic to version v1, which maybe I still have it there. Okay, so now all the traffic goes to service 1. And if this works, finally, yeah. And you see here, this is the movies, and one important thing is this one. This is the host who are serving this page. And notice that this movies v1. So I need to buy some films. Infinity Wars, how many copies? 2. I would say 2. Captain Marvel? What, how? 0? Well, then I don't buy it. Okay, I buy 2 Infinity Wars. And add to cart. So if I go here to the cart, you see that I've added 2 Infinity Wars, and again, the host is the movies v1. So I can go again to movers, and I'm going to reroute all the traffic to version v2. The only thing that I need to do is do a replace of source main Istio virtual service v2. So I'm just rerouting the traffic from v1 to v2. Then I can go nope, here and not here. I refresh. Notice here, now there is v2, there is no v1, and the shopping cart is still here with one element, which is the 2 of Infinity War. And I can go back here and I can buy this one, which my daughter will be really happy. And of course I have here both of the movies. And if I detect that there is some error in v2 and I want to get back to v1, I just need to go here, apply this file. And now when I just refresh, you see that here is the v1 again, and the movies. Where are the movies? Well, there is the link here. You see that there is the How to Train Your Dragon and Avengers. So I'm not losing the state anymore. And I can just switch all the time from version 1 to version 2 without much problem. Then, next example is the one that you mentioned about what's happened when there is persistence. What's happened when, because now it's really easy, right? You have the Redis there, you're just sending and see what's happened. To make this, I'm going first of all explain you one thing. So what's happened when we have a persistent state? When we have the database. Basically, I'm going to explain you the most complex example. With this example, then you can, take the idea and apply it to any other transform that happens on a database. And this one is that and update the column name. For example, you've got the column name and you want to rename it to full name. I've got version 1 with the database with a column called name. Then I want to rename this column to full name. So what's happening if I do, for example, a canary release? It means that if the column name does not change, it's not a problem. But if the column name changed, then some users might find some problems, right? Because one column is called full name because you renamed the column, and then 1% of the users will get it the correct response, but 99% of the users will receive column name not found. So how to do it? The first thing that you need to do is do something like this. You've got version 1 that needs to read and write to name and full name. So you are duplicating the fields. Any read and edit write of version 1 should go to both of these columns. And the version 2 just reads from the full name. Notice that in this way, what you are getting is that if there is version 2 behaving incorrectly, you can always get back without losing anything. And of course, if there is a write, because at the end the users will write something, they write to both full name and name. The reason of this is that if version 2, you need to roll back it to version v1, all the data is still a name, although your final step is just having full name. This is for the first time. Then, remember that we've got version 2 having the right to name and full name and reading from name. But you want to end up by removing name. So the first thing that you need to do with version 3 is just do something like that. I copy all the previous data from name to full name. Because remember that you have added full name at the middle of, that you've added maybe after 1 year of running this application. So you need to copy the previous data from name to full name. And probably you will use something like a Spring Batch to batch all this information from column to column so you don't lock the full database. After that, this version 3 will start reading all the information from full name. Since you've copied everything from name to full name, then you have not lost anything. And the writes still happen to name and full name. And you need to do it in this way, again, for the same reason. If version 3 has any error and you need to roll back, you still need to be able to work with version 2. And if you see version 2, the read is happening from column name. So you still need to write to column name. And the last thing that you need to do is, like, I have now version 3, which writes to both and reads from full name. What I need to do is just start read and write from full name. So after 3 steps, your application has migrated from reading from column name to reading and writing to full name. So you need to do it in these 3 steps. If you don't do it in that way, I know that it's somehow complex, but if you don't do it in that way, it's impossible to guarantee a backward compatibility. With zero downtime, of course, you can try zero downtime and see what's happening. Without zero downtime, just stop everything, start everything, and see what's happened. But if you want to do it with live code, you need to do it following all these steps. So let's see now this example. I've got here, I'm just, this is a Kubernetes cluster. When it's OpenShift, but at the end OpenShift it's Kubernetes. So you see that I'm going to use kubectl all the time. And this is that Istio tutorial. Okay, now I've got next, well, I can wait. Let me open, so it will be easy. Git Istio tutorial recommendation. Yeah. And if you see again this Canine, I've got a customer, I have a preference B1, I have recommendation B4. I mean that because B1, B2, B3, it's for other things, and now B4 is like the standard version, like the B1 from normal way. And I have here a Postgres, and if you check what this cause of Postgres contains, I can do a PSQL. Admin recommendation. Select. Okay. And you can see that I have an ID and a name. The name is Star Wars: A New Hope, and a Star Trek: First Contact. This is just the name, and I want to rename this name to another thing. Of course, if I do here a call, you see that I'm getting customer preference recommendation before, Star Wars: A New Hope, Star Trek: First Contact. Now, what's happening if I want to add, for example, a new movie? I just need to do a call -h content type, and I'm going to add, for example, Avengers Infinity War. Now I've added a new movie to the old version, so of course I go here and I do the select. You see that there is this movie as well, and I do here the call. Then I've got Star Trek, Star Wars, and Avengers. Now I want to deploy a version B5, which is the start of the rename. The only thing that I need to do, I'm going to do it from here, is kubectl apply, and the deployment that I'm going to use is B5. Notice that what I'm doing here is just taking deployment B5, which is my normal deployment, and I'm just passing through kubeinject, which modifies this YAML file to add all this Istio magic. And there is no because it's at Kubernetes. Okay, now I'm just deploying the next version, which is almost running. Remember that this new version, what it's doing, just creating the column name, and this new version is reading from the old one, but writing to both. Now it's running, and if I do here a select, I'm going to fix this, see that there is a movie name field. There's a new field, right? And the old field. I want to rename from name to movie name. Then, again, what I need to do is reroute the traffic to this B5. To reroute the traffic to B5, I just need to do Istio replace -f. Istio files, virtual service, B5. Now I'm just sending all the traffic to the B5 version. And if I do a call, notice that I'm getting recommendation B5 with the 3 movies. What's happened if I do now a call, and for example, I add another movie, for example, Frozen would be a good movie. Now they are going to release Frozen 2. It's going to put Frozen 1. Now what's happening if I do here a select? You are seeing that Frozen are added to both columns. And of course, I can do here a curl, which is Star Trek Infinity and Frozen. If I notice that, oh, now there is an error in this version B5, I need to switch back to B4, I can just do istio-ctl, replace -f, istio files, virtual service, B4. Now I do a curl, and of course now it's B4, but the Frozen movie is still there. So notice that the version before didn't know anything about movie name field, because that was not created yet. But since I've write it to both of the places, then I get it, the data in both. Then, let's suppose that everything works as expected, and the B5 is correct, so you can just go back to B5, and I deploy the next step to this migration, which is deploying the B6. So I just need to go do a kubectl apply of deployment B6. Well, first of all, to not get crazy, I'm going to do a kubectl delete all -l app recommendation version B4. So now, since B5 is good, then I can just undeploy B4, and I'm going to redeploy B6. So now I've got B5, and then I have B6. And when I have here, get pods, still starting. Basically now with the B6, what I'm doing is copying from the old data to the new, from the old column to the new column, and now reads and writes happens in the new columns. Let's see. Okay, now it's everything running, and I do a select here. You see that now Star Wars or Star Trek and Avengers that came from before are copied to movie names. Notice that in the previous select, these elements were not there, but now they are there. So again, I can just do an istio-ctl replace istio files virtual service B6, and I can do a call, and I'm getting all the movies from B6. Again, if I can just switch back to, that if you want, I can do a call adding some data. For example, now let's add any movie. Okay. Toy Story 4. And of course I can do a call, and then for Toy Story it's here, and again I can, if I detect any error, I can switch back to the number 5, and I can do a call, and of course Toy Story 4 is still there. The final step will be just to delete, I think that delete is here, B5, well, not because I'm still the rules pointing out to B6, so I don't want to screw envoy, replace to B6, and then I can delete B5. And finally, I can just deploy the last one, which is v7, which is another version, which now I'm just changing where the data is read and write. Now the reads and writes are happening from the new columns. So in terms of new columns, it's happened nothing. But what's happened now if I do this? And I'm going to change this to v7. Of course, the call still returns v7, but if I add a new then I don't know exactly what I have here. Another one. An ape movie. What? Sorry? Terminator. The one? I mean the original one, yeah, because now there is a lot of Terminator, right? Okay, I do the curl, but now notice that if I do a select, Terminator is just in the new column, not in the old one. And you said, and this is going to work if I do a rollback to the version 6. Of course, because version 6, you just get it from the new one. So I can just do istio.ctl replace, I go back to 6, I do the curl, and whoop, Terminator is there. So I'm just, doing all these 3 versions, always back compatibility. You've seen that I've been switching from the old and the new and adding data, and the data is never lost. So we're almost done. If you want to check all these examples and go deep inside Istio, you can go to this Istio tutorial, which is everything is explained. And there's also a cheat sheet in case that you want to, you have some knowledge of Istio and you just want a summary of everything. One of the things that you might find is that what's happened when I'm mirroring traffic, right? What's happening if I send in the request to 2 services of 2 different versions and there is an insert, then I'm doing 2 inserts to the same database, right? To avoid this, you can use 2 approaches. Well, there are actually 3, but I will explain you 2. The first one is using synthetic transactions. Synthetic transactions is just detecting that the traffic is sharded traffic, which is really easy with Istio, and then just roll back all the transactions. So you receive 2 inserts to service BB1 and service BB2. They are sending 2 inserts to the database, right? But when the database responds to the V2, then there is a rollback. So this insert never happens inside the database. Another option is just create a virtual or virtualize the database cluster. So you've got something like this. I've got the production database, and then I have a virtual database, for example, using Jade, which is an open source tool. And then all the reads happens from production, and all the writes goes to a throwaway database. So you're just shadowing the traffic to both of the services. The inserts goes to this throwaway, and then when you switch from V1 to V2, then you just need to remove all this throwaway database. We're almost done. Well, I mean that it's somehow difficult, let's say in this way, to maintain a zero downtime deployment with microservices, but just forget about what you've done in the past and just start applying these new techniques with Istio, which is really easy to do, as you've seen. Proceed with caution, because remember that there is in the case of renaming a column, there is still a column there with all the data, and probably no SQL administrator will allow you to delete this column. But in theory, the last step should be delete the old column. And well, I mean that there is also this kind of books where some of these concepts are explained. Basically, this one, which is migrating to microservice databases from Edson Yanaga, explain this technique and other use cases, and you can download it for free from developers.redhat.com. You just go there, you register, and then you can download it, all of them. And that's all. If there is any question, just can follow me on Twitter or even send me an email. I mean that some people ask me, can I send you an email? And yeah, you can send me an email because it's here, the email. If not, it will not be here. Thank you.